like to talk today perspective of exposome research on birth cohort study. Yesterday, Atsuko introduced our Hokkaido study birth cohort. So I will add a little bit more and more focus on the exposure side and some association with asthma and allergy. So this is the content. So this morning, Rob already Rick explained very detail about the exposome. So I will also prepare my slides, so make a little bit overlap, but I will add a little bit different context of, I hope. And next, exposomic pedagogical study, because we are working on pedagogical study, then how we close and as much as we take as much as information from cohort. Then integration of exposome and findings from birth cohort study, and the last challenges and perspectives for exposome research in cohort study. So large population environment risk factors remain unknown, poorly defined, although environmental contribution to the disease risk is estimated. This exposome, the term of exposome, was coined to encompass all the environmental factors to which humans are exposed through their life force dimensions. So 3 overlap samples you can see. So one, so A is personal exposome, which is contaminant and diet and physical activity, and also about smoke and infections. And B, this is external exposome, which means include factors such as urban environment, climate change, and social capital stress, and the social capital and traffic pollutant. And C, internal exposome, which is the biological responses came from A, personal exposome, and B, external exposome. Then include internal biological factors such as metabolic factors, gut microflora and inflammation, and also oxidative stress. So to track life force dimension, a prospective birth cohort study is one of the best study tool, study design. So birth cohort study is a longitudinal research design that follow a group of individuals born from follows a group of individuals born from prenatal period and collect data on various health and developmental outcomes throughout their lives. So I would say there are 3 key features as following. One is longitudinal design. So follow a group of individuals from prenatal period. Then second one is collect data on various health and developmental outcomes throughout their lives. So comprehensive data collection, which includes information on health, lifestyle, environmental exposures, and genetic and socioeconomic state factors. And also multidisciplinary approaches. So this involves collaboration across fields such as epidemiology, genetics, and psychology and public health. So in summary, integrating exposome perspective into birth cohort study enhance the understanding of how environmental exposure influence health from early life onward, support the development target preventive measures, and contribute to more comprehensive and personalized approach our Hokkaido study introduction. So we recruited pregnant women from 37 hospital or clinic around Hokkaido. So we are now in Sapporo here, but we recruited all over Hokkaido area. So in total, 20,900 mother and pair are now participated. So currently, the age of kids is already achieved pivotal age, and also some of them are already adult 18 years old. So now ongoing 12 years and to 22 years old. So our target environment contaminant is listed in here. So these are POPs, organochlorine, pesticide, and dioxide, PCBs, hydroxy-PCBs, and PFAS, and methylmercury. And these are more short half-life chemicals, such as phthalate, bisphenols, phosphorus flame retardant, nonylphenol, neonicotinoid, and organophosphate pesticide. So these are our aim. Four aims are already introduced by Atsuko, so I will skip this part. So this is our mainstream of the Hokkaido study. So after recruitment, pregnant women, maternal blood samples were collected. At the same time, we collected questionnaire as baseline survey. When baby were born, we collected maternal blood and also cord blood sample, and also the birth outcome were collected by doctor questionnaire, doctor records. And after that, we following up those children, mostly by questionnaire survey, filled by their mother, and some of the time period when kids have become 7 years old, and 9 to 12 years old. And last one, recently we started 14 to 17 years old. We conducted face-to-face survey to collect more dense information such as medical examination and neurodevelopment. And also we lent personal devices to monitor electromagnetic frequency to affect their neurodevelopment outcomes. And also we collected house dust sample from their home, and also urine and blood sample were collected by doctor or pediatrician. So this table is quite a busy table, but this is the list of our main publication which have already published relationship between the health outcomes and associated risk factors. So from top, the birth outcome and child growth, and thyroid hormone levels of mother or cord blood, and reproductive hormones and adipokines, which represented child growth and future destiny, and sexual dialogue from insulin. And also neurodevelopment and asthma and allergy, and also infectious diseases, and gene environment interaction also we conducted, and epigenetics and exposure level. We are also we think this is also important in a cohort population, because environment chemical is changing due to the regulation and the ban. So the continuing at certain point to point, we collected biological sample to monitor or to understand how the exposure level of chemicals. So I will move on to integration of exposome and findings from birth cohort studies. So this photo I like to show this picture. When I was a PhD student, we are visiting their participants' home to collect the dust sample. So every day we drive a rental car to visit their home to collect the floor dust and also seeding dust, higher place dust. Then after coming back to the lab, we iterate the dust sample and analyzed. This time we measure phthalate and PFRs in house dust samples. So this is in exposome content. This is the external exposome. Then we examine the association between phthalate and PFR in house dust and asthma and allergies. So higher level, this top part is phthalate and the bottom part is PFR. The higher level of DHP and DINP and DBZP and DIPP were associated with increase of allergic conjunctivitis, allergic rhinitis, and atopic dermatitis. And also the red represents the children and the blue square is means their parents. So when you compare the red and the blue, the red is clear, red showed clear dose response relationship compared to the adult. That means children are more vulnerable population than adults because children this time children is school age children, so they stay more home than adult, and also their height is not so high. So they also in Japan we very frequently sit on the floor to watching TV and playing TV game and so on. So we think more close, we easily exposed from those chemicals to dust sample. As for PFR, a higher level of TNBP and TCIBP were associated with risk of asthma and atopic dermatitis. So this time, this slide showed exposure level of PFAS and phthalate and BPA and PCB and mercury. Then this one is secular trend, time trend of P4, PFOS, and PFNA, PFDA from 2002 to 2011. So as P4 and PFOS, as you know, the Stockholm Convention after 2009 or before 2009 already regulated and also decreasing using in manufacture. So we saw the clear decreasing trend in P4 and PFOS. On the other hand, PFNA and PFDA were increasing. And this showed, I do not explain more detail, but we also measured PCBs and mercury in hair sample. And this one is PFOS and phthalate metabolite from mothers and bisphenol. So in Hokkaido Cohort, we also interested in their birth outcomes, such as birth weight. Already shows explained index result, but we also found the association higher level of PFAS in this time PFNA and PFDA, longer carbon chain than PFOS before already banned. But those even not regulated PFAS already significant association with decreasing birth weight and birth length of baby. As for allergy and infectious disease, this one left graph is prenatal exposure to PFAS and asthma and allergy and infectious disease at 4 years of age, and following up until 7 years old is right figure. So as for asthma and allergy, the increasing level of PFAS, risk of allergy is decreasing. And on the other hand, as for infectious disease, increase of level of PFAS and PFDA and P4 increase risk of infectious disease and pneumonia and RSV virus infection. So already several publications and scientific evidence suggested that PFAS has immunotoxic effect, and our result also in line with their findings. And I'm sorry, very busy slide. And this one is also exposure level, but this exposure level is from children. So we also, as I explained, we also collected biological sample from children. So this time, phthalates and PFRs and bisphenol were measured from during sample from children, and PFAS was measured from blood sample of children. So phthalate, as for phthalate, almost our targeted phthalate, most of all children was detected phthalate from their urine. As for PFRs, some of metabolite are very high, but some of metabolite is not detected. So in the metabolism pathway in urine, so some compound metabolite has more dominant, but some are not dominant. So in statistical analysis, we mostly use highly detected compound metabolite, or sum up those metabolites which have same parent compound. Then we use for statistical analysis. As for bisphenols, also we target 7 bisphenols, but seven out of 3 were detected more than 80% from the urine sample. So this one is I not want to explain more detail, but not legacy PFAS, but also quite newer alternative PFAS were detected from their blood sample. From this one collected in 2017 to 2019. So quite after the PFAS and P4 regulation. And this one is secular trend of urinary phthalate metabolite, and also alternative plasticizer is shown in this graph. So left graph is legacy plasticizers. So in Japan, we don't have a clear decreasing or increasing trend for legacy legacy plasticizers, but alternative plasticizers such as DEHTP and DINCH is alternative for DEHP. So those compounds and plasticizer were showed increasing trend from their urine. These samples were collected in 2012 to 2017. So as for prenatal and postnatal exposure of those shorter half-life compounds and asthma and allergy were also examined. As for prenatal exposure, the increased DHP had associated with risk of food allergy and any allergy. Any allergy means eczema and wheeze and rhinoconjunctivitis. One of them has a positive, we defined any allergy, prevalence of any allergies. as for postnatal exposure, in phthalate, D and P were associated with wheezing, and PFR, TD-CIPP, and TBOEP were associated with increasing risk of wheezing. However, bisphenols, bisphenol S, were associated with decreasing risk of wheeze in this time. So Joel yesterday explained mixture model. So this one is not different group of chemicals. This one, this showed three different statistical model. The top one is single to single compound and single outcome. So this time TDCI exposure is TDCIP, and outcome is wheeze, and outcome is eczema. Outcome is like this. And this one is inosinophil, phenol, and IgE and eosinophil. And B, this one is QG computation. So yesterday WQS and BKM1, but this time we wanted to show the both effect, negative and positive. So we applied QG computation. Then the C, this one is a BKM1. So red one is significant result. Then include within PFRs, TDCIPP had a strongly positively associated with phenol, a higher phenol level. Then in the same children, we also have data on phthalate. So we combined mixture chemical association statistical model. So this one only showed BKML model. So if the increase the complex mixture is increasing, the risk of wheeze will increase. So here is the dominant compound, TDCIP, and DINP here, and TBO is here. So we will say that TDCIPP is a more contribute to the risk of wheeze when we consider the mixture of chemical is PFR and phthalate. However, we have bisphenols in same children. So I want to see how the effect of mixture of three group of chemical to child food wheeze. This is the result. This is not significant. So we cannot say that those three group of chemical increase children's wheezing is become risk of wheeze become risk. Three of chemical become risk. So when we look at closer, so bisphenol S, the secondary highly contributed chemical, we will say that is strongly associated with negative direction. So maybe this one is conflict to the positive direction. So if we compare this result and this result. So we don't expose to chemical, not only three chemicals, we also expose other chemicals and also from diet and air pollution. And so this is a kind of our direct dilemma of interpret result of chemical exposure as considered as mixture. So we don't have any conclusion currently, but this slide shows our summary exposure to PFAS and health effect. Some of neurodevelopment part and hormone part already as introduced yesterday, this part. So today I shortly briefly introduce the birth rate and also asthma and allergy of related to PFAS. So kind of matrix we have. So this part and timeline, life course, and this column show the green column show the exposure factors. So external exposome and also some of internal exposome and personal exposome. So we still have a lot of work to fill the exposome context. Then recently, this very impressive study was published from Helix European project. This project is also same concept, have exposome as personal exposome and external exposome, and they also omics as internal exposome. So they collect a lot of data from maternal sample and also children at age. So population is not so big, 1,300 from 6 European projects. So they also already harmonized to obtain the same aim and goals. So in our Hokkaido study, we have only one study. Then we are working very tiny work every day. Then for us, is this achievement quite far. So we like to collaborate this kind of to achieve this kind of goal. Then so yesterday Richard talked in a grant. So we are very happy to discuss about sharing, collaborate to other partner to see the same objective and same goals. So yeah, this one is their findings. So very impressive findings. They have a lot of exposome and a lot of outcomes also, health outcome, and many also data analysis also very impressive work they have done. So this is the challenges for exposome research and cohort study. So I want to read every detail already explained by Dick. So the complexity, data collection, and data integration and management, and analytical challenges. This is very big, and ethical privacy content. So more detail, more personal data we need to collect to achieve exposome. So also in cohort, we first recruit mother of children as assent. But now children is becoming adults. We need to take informed consent from children. This is also a challenge for us. Also findings I already called them, perspectives and advancing in technology and data science and informatics. This is a very big challenges, and enhances the collaboration. I already told. Then policy, public health implication. This one is also important. Informal policy. So our findings can be used for policy to stakeholder. So we are also, this is why we are doing cohort study of the environment health and children health, because we want to have a good future for children. So this one is also very important and perspectives. So also personal health, also Robert already told very detailed, so I don't say that additionally. Thank you very much.
Thank you.